In this tutorial, I'm going to discuss completing the square, and I'm going to use tiles. The red tiles are 1 by 1, and so are the blue. The length of the blue tile is x. The length and the width of the purple tile is x, which makes the area x squared. The 2x represents the two blue tiles. And finally, the red tiles are -3. This equation right now is equal to 0, and because nothing's in that box on the right hand side. My first objective is to get rid of those 3 red tiles, a negative, and I do that by adding 3 green tiles, or 3 positive tiles, to both sides of the equation. And this cancels out all the red tiles. What I did algebraically is add 3 to both sides of the equation. So now I have x squared plus 2x on the left-hand side. And on the right-hand side, I have equal to 3. Now the next question is, how many green squares do I add to complete the square? In this case, it's 1. And I add 1 to both sides of the equation. In this case, I'll do it algebraically as well. So now I have x squared plus 2x plus 1 is equal to 4. Now I have the equation x squared plus 2x plus 1 is equal to 4. The length of the top of the square is the blue x plus 1, or x plus 1, which is the total distance. The height of the square is x, the blue x, plus 1, or again, x plus 1 for the whole distance. And now these become the factors of that equation above. So I have x plus 1 times x plus 1, both sides of that square, or both sides of that rectangle, I should say. Again, this is all equal to 4. Remember, these are to the first power, x plus 1 to the first power, and x plus 1 to the first power. So when I multiply two things, I add the exponents, 1 plus 1, so that equals 2. So I have x plus 1 to the second power is equal to 4. Now I can solve for this equation. I take the square root of both sides of the equation. What I do to one, I have to do the other. Sides, that is. So I have x plus 1 is equal to 2, and x plus 1 is equal to -2. -2 squared is 4, and so is 2 squared is 4. Now I subtract 1 from both sides of the equation to isolate my x. So now I have x is equal to 1 on the top equation. I do the same thing for the bottom equation. So I have x is equal to -3 in that case. So if I take these numbers and plug it into my original equation that I started with, put 1 squared plus 2 times 1. I think 2 times 1 should move over there. There it is. Minus 3. All this equals 0. 1 squared is 1 plus 2 times 1, which will be 2. Minus 3 is equal to 0. 1 plus 2 is 3, so I have 3 minus 3 is equal to 0. And now let me do the -3. I have -3 squared. I think there it goes. So I have -3 squared plus 2 times -3 minus 3 is equal to 0. -3 squared is 9. 2 times -3 is 6, so it's 9 minus 6 minus 3 is equal to 0. 9 minus 6 is 3, and 3 minus 3 is equal to 0. So if I graph the equation, the purple line is the graph. This graph crosses the x-axis at -3, 0 when x is equal to -3 and when x is equal to 1. That's what we do when we solve for these equations. We figure out where it crosses the x-axis. We're moving right along, and up next is a video. It's about 3 minutes, and it's a little bit more complex.